In this video, we'll be looking at applying our trigonometric equations. Which really means we're just going to be looking at some word problems. So what I've done is in our assignment on Google Classroom, you can print this page right here. So I've put this, maybe just a blank page, and if you have the ability, you can print it. If not, just follow along and maybe either copy the problem all the way or copy just the key things that you need. Okay. So we're going to do some of these problems. Now there's three things that we're going to do for each problem, and I'll draw those three things right up here, or write those things. So the first thing we're going to do is draw a picture. So that'll be the very first thing we do is draw a picture. The second thing we will do is set up our trig equation. And the third thing we will do is solve. So we draw a picture, we set up our equation, and we solve. Okay, so now let's, before we begin, we're going to have to review the three trig equations that we'll use. So the first one is our sine equation. And we're just going to use that acronym that we've been talking about for the past week or so, just to remind us. We're not going to write out all three, we're just going to use this to remind us. So we have SO, Ka, and then TOA. So a quick refresher. So states that sine is equal to opposite over hypotenuse. Ka stands for cosine is equal to adjacent over hypotenuse. And TOA is our tangent is equal to opposite over adjacent. Okay. So let's dive in and tackle these problems. So a ladder leaning against the wall makes an angle of 65 degrees with the ground. If the foot of the ladder is 9 feet from the wall, how high on the wall is the ladder? So first thing we're going to do is draw a picture. Here's my ladder. Here's my wall. There's my ground. So if you need to label it, go for it. So we got wall. We got ground. We have our ladder. Okay, so the ladder makes a 65-degree angle with the ground. Okay, so ladder leaning against the wall. So here's our ladder leaning against the wall. Makes an angle of 65 degrees with the ground. If the foot of the ladder, so the bottom of the ladder, the end of the ladder, is 9 feet from the wall, so now we have this is 9 feet. How high on the wall is the ladder? So how high on the wall is the ladder? So this is what we're looking for. Here's our x. Okay, so now that we have our picture drawn, we can label and then set up our trig equation. So we're going to label our hypotenuse as the ladder itself. We have our focus angle right down here, the 65 degrees. The wall is opposite our focus angle. And the ground is adjacent our focus angle. Now I have an opposite, that's our x that we're looking for, and adjacent that I'm working with. So which trig uses opposite and adjacent? Sine, cosine, or tangent? We're going to use tangent. So we can say tangent of our focus angle is equal to opposite over adjacent. Our focus angle is 65. Opposite is x. Adjacent is 9. So I just did tangent of our angle is equal to opposite over adjacent. Tangent is equal to opposite over adjacent. Okay, now we'll just use our calculator to simplify tangent of 65. So tangent 65 degrees is equal to 2.14. 2.145. So I have 2.145 is equal to x over 9. Now we'll just set up for cross multiplying and solving. So I get x, 1 times x is equal to 9 times 2.145. 9 times 2.145 is equal to about 19 feet. Like so. And then we're done. So we draw a picture, we set up our equation, we solve accordingly. Okay, let's do another one. A wire attached to the top of a pole reaches a stake in the ground 15 feet from the pole and makes an angle of 47 degrees with the ground. Find the length of the wire. So for all these, we're going to be drawing a right triangle. So you can go ahead and start by drawing your right triangle. And then we'll start labeling. Okay, a wire attached to the top of the pole reaches a stake on the ground 15 feet from the foot of the pole. So here's our ground. Here's our pole, and here's our wire. The wire reaches a stake 15 feet in the ground 15 feet from the foot of the pole. So from the foot of the pole to the wire is 15 feet. And makes an angle of 47 degrees with the ground. And find the length of the wire. So we're trying to find this length. So this will be our x up here. Okay, we have our picture drawn. Now let's label it for our trigonometry. So I got my hypotenuse, always across from the right angle. I've got my angle of focus down here. Opposite will be over here on the pole. The pole is opposite my angle, and the ground is adjacent my angle. Okay, so which one uses, so it looks like I have an adjacent side, and I'm looking for the hypotenuse, so we want to find something that uses adjacent and hypotenuse. Adjacent and hypotenuse. So A and H, that's going to be cosine. So let's set up our trig equation. So cosine of my focus angle is equal to adjacent over hypotenuse. So cosine of my focus angle, 47, is equal to adjacent 15 over hypotenuse, which is x. Okay, now we have our equation set up. First two steps done. Now let's go ahead and solve. So we'll use our calculator to simplify. So I'm just plugging in cosine 47, and I get 0.682. So 0.682 is equal to 15 over x. Write in my hidden 1, and now cross multiply and solve. 0.682 times x, there it is. 1 times 15 is 15. Now I'll divide by the decimal, and we're done. So 15 divided by 0.682 is equal to 22. So x equals 22 feet. The wire is 22 feet long. So that's like the name of the game here. So far we're seeing a pattern, I hope. We're going to draw a picture. I'm pretty much going to draw my triangle the same way every time. I'm going to label my triangle accordingly, set up my equation based on my triangle, and then solve. Okay, let's do it again. A boy flying a kite lets out 200 feet of string, which makes an angle of 43 degrees with the ground. Assuming that the string is straight, how high above the ground is the kite? So we're going to have our boy is down here. He's got a string to his kite up here. And then we have our ground down here. So this is our string. This is our ground. And this is kind of like an invisible line right here, because this is just the height of the kite. Let's make that a dash line. Okay, so I drew my picture. Now let's label it. A boy flying a kite lets out 200 feet of string, so there's 200 feet of string, which makes an angle of 43 degrees with the ground. Okay, and how high above the ground is the kite? So there's our x over on this side. Okay, so we have an opposite side and a hypotenuse. So that's going to be sine. So we can set up our, let me label everything. Hypotenuse, opposite, adjacent, and our focus angle. So we're looking for the opposite and we're given a hypotenuse, so we'll set up a sine equation. So sine of our focus angle is equal to opposite over hypotenuse. So sine of 43 is equal to opposite x over our hypotenuse 200. We'll simplify our sine, and then we'll do some cross multiplying. So sine of 43 equals 0.682. Then we'll cross multiply. 1 times x is x, and 0.682 times 200 is equal to 136.4 feet. The kite is 130, we'll just say about 136. The kite is about 136 feet above the ground. Okay, so let's do one more. We're going to draw a picture. So a ladder leans against the building. The top of the ladder reaches a point on the building which is 21 feet above the ground. The foot of the ladder is 9 feet from the building. Find the measure of the angle which the ladder makes with the level ground. So we are given a picture. We have our ladder. We have a building. And then we have the ground. The top of the ladder reaches a point in the building which is 21 feet above the ground. So we're on the building and we're 21 feet above the ground. So that 21 is going to go right here. The foot of the ladder is 9 feet from the building. So the foot, the bottom of the ladder, is 9 feet from the building. So that's going to be across the ground, like so. And find the measure of the angle. So we're looking for the angle. So our x is going to be our angle. It's in there. Okay, so here's my focus angle, the x. My hypotenuse is always across from my right angle. And then the opposite side will be our building, and our adjacent side will be the ground. So it looks like I'm given an opposite and an adjacent and a focus angle. So which trig equation uses opposite and adjacent? Tangent. So we'll say tangent of x is equal to opposite over adjacent. So 21 over 9. Okay, so this is the this is an inverse we're going to have to use because x is inside of my trig. So I'm going to have to simplify my fraction and then just apply the inverse. So tangent of x equals 21 divided by 9 is equal to 2.333. Then I'm going to use my inverse tangent to get rid of tangent. So I need to get x by itself, so I'll use inverse tangent to get rid of tangent. Whatever I do to one side, I do to the other. So I have x equals inverse tangent of 2.333. Plug that into my calculator. Inverse tangent, 2.333, gives me 66.8 degrees. Like that. And that's how we can use trigonometry to help us solve real life word problems. So thank you very much for watching this video, and I hope you have a great rest of your day.